we're here to talk about building first-class REST APIs with Symfony. My name is Michael Cullum. That's my Twitter handle. I'm up here for the next sort of 50 minutes or whatever, so feel free to tweet abuse at me or feedback or just photos of slides, that kind of thing. My Twitter handle will be in the corner of all my slides anyway. I work for a company called Bud. I actually started working for them 2 weeks ago now. But we're hiring. We do cool stuff with smart money management and marketplace and all that kind of jazz. So if you're interested in APIs and data and security and that kind of stuff, we've actually got a booth downstairs to come chat to us. I'm part of the Symfony core team. I'm the security lead for Symfony. So if any of you guys want to chat about security or Symfony, again, come chat to me. And then finally, the PHP FIG. I'm part of the core committee, so we're kind of the technical steering group for the sort of FIG generally. But I also lead the security working group. There's a security theme there. Yeah. So we're here to talk about APIs. And very specifically, we're kind of here to talk about REST. Who's used a REST API before? Almost everyone. Who thinks they know what a REST API is? OK, interesting, because there are a bunch of people that said they've used a REST API, but don't think they know what a REST API is. So what actually is a REST API? And REST APIs have been around a really long time. It actually originates in 2000 when there was a paper by a guy called Roy Fielding. And it was an academic paper. It was incredibly dry. It's very boring. I would recommend reading it, but you might want to read it in bite-sized chunks. It's a bit boring. And REST, what it actually is representational state transfer. So what does that mean? And obviously that's where you get the REST. But we're looking at representational state transfer. So it's all about how we can communicate one thing from another, how we can communicate state. State is all about what does a system look like? The state of me right now is that I'm on stage, I'm male, my name is Michael. Some of these things are relatively immutable. Some of these things might change. The fact later on I will not be on stage, so part of my state will have changed. In order for this, in this paper, there are a series of different principles that Roy suggests, and these are the things that you actually need in order to comply with REST. Because actually, the spec doesn't mention anything about HTTP verbs. We'll come on to that later, and that's what people think of when they think of REST. They use HTTP verbs, status codes, all that kind of stuff. And for 100%, you should use them. But that's not what the spec is really about. So the first one is uniform interface. Uniform interface can actually be divided into a bunch of sort of smaller categories, which I think kind of are a much better way of explaining it. So the thing about a uniform interface is it means that every single REST API kind of should look the same. Once you know how to interact with one REST API, you should know how to look at every REST API. It should be really simple to use. You shouldn't have to have a guide on how you can request data or what that data looks like or anything like that. And there are a series of different sort of things that you can do to achieve this. One of them is your URL should be resource-based. So, for example, you might have /users /1 /comments. So you're all of it, but that shouldn't necessarily correspond to what is in your database. In your database, it should be different. It should be resource-based. Another part of the uniform interface is the ability to manipulate your state through representations. And what that means is that if you've done a get on something, if you have a representation of an object, then you should have everything you need in order to modify that. I should be able to do a put, for example, and I should have all the different fields that I need for that. It should be able to give you everything that you are able to then modify back. It should be self-descriptive, so use MIME types. Say if you're sending JSON, if you're expecting JSON. If you're expecting YAML, then say you're expecting YAML. If you say you're expecting or receiving or sending XML, then say it. Although, who wants to send XML really anyway? And then finally, something that a lot of people talk about is hate OAS, which means hypermedia as an engine of application state. And what that basically means is you're transmitting stuff over hypermedia, which means use it. So that means link to, if you're doing pagination, then link to that. If you're talking about another object, so for example, you have a REST endpoint for a blog post, and you mention an author, then have a link to more details about that author. And that's a really important part of REST that nobody really does because they don't think it matters. But the whole point of the uniform interface is that every single REST API should be the same. It should be really easy to get started with a brand new REST API. So the next principle is that it should be stateless. And what this means is that you shouldn't have any sessions. Sessions just shouldn't exist in APIs. Everything that you need in order to be able to complete that request should be self-contained in that one request. You should be able to give me a curl command that you've run, and I should be able to go and run that on my machine, and that should just work fine. So your authentication tokens and all that kind of stuff, it needs to be actually in the body, in headers, in the query string, in the resource URI, or in the content of your request. It needs to be cacheable. Who sets cache control headers on every single one of their APIs? Okay, one person. In which case, none of the rest of you have all of those APIs as truly RESTful. Even if it's not cacheable, you need to say explicitly that it's not cacheable. This basically means that clients can know whether or not they can cache it. And the thing is, a client doesn't necessarily mean like a browser or someone using POR or Postman to interact with your API. Sometimes it's actually just the fact that they want to be able to, it might be Varnish, for example. You want to have all of those clients, or whoever your client is, being able to understand, can they cache that data? Is that safe? And not just trying to make assumptions. Client server. So another really important part of this is that your client and your server need to be distinguishable. It needs to be, you shouldn't have necessarily your client shouldn't care about your database. It shouldn't care about your data stores. That's not its responsibility. That's the responsibility of your server. So you should, if you have an API spec like OpenAPI 3, highly recommend building your specs in that format, then you should be able to build a server and you should be able to build a client completely independently just based on that specification. They shouldn't have to know about anything else or any side effects or anything underlying because the actual having your servers like not interacting differently from your clients means it's a lot more scalable. A layered system. So a layered system kind of goes back to what I was talking about earlier, in that you shouldn't ever know if you're talking to the end user. You might be talking to an intermediary, and that intermediary, it might be a proxy. It might be that you're talking to a JavaScript application, and then that JavaScript application is doing something else and talking to someone else. It could be the fact that you're talking to another API, which is then talking to another API. If any of you saw Anthony's talk earlier, this morning on microservices, sometimes you might have one API talking to another API, talking to another API, and they might add security or do various different things. One might be internal, and one might be for your developers, external developers through a marketplace to interact with your product. So having a layered system allows you to introduce security policies, for example, at a different step, or having different kinds of authentication on different APIs. But you shouldn't care if you're actually talking to the end user. You should just care about the person that you're talking to next. And finally, code on demand. This one's really weird. Does anyone know what this is out of interest? Okay, cool. This is something new for everyone. There's this weird part of REST that basically says that you should be able to give it code to execute, like JavaScript or Java applets, and the code that can then be run on the server. It's a little bit weird. I don't think I've ever actually seen people use REST in this way. It's therefore generally considered to be an optional kind of principle in order to be RESTful, and it's kind of a bit legacy. As I said, it's from 2000. So what? That was really dry. That was really boring. You've just explained this paper to me. What does this actually mean for my application? Those are all principles to kind of bear in mind when you're building your API, but actually how do we do that in practice? And I mentioned HTTP response codes earlier. And you should. Ultimately, what you're always trying to do is use HTTP well. Yeah, that previous slide shouldn't have been there. Sorry about that. Okay, rewind. Use HTTP well. HTTP is your friend, and ultimately the REST spec doesn't talk about HTTP at all. It relies on the fact that you use whatever technology you're using to its full, in that uniform interface way. It should know how every single HTTP REST API works. So one of the ways to do this is with HTTP verbs. So that's get, put, post, patch, delete. Who uses all of those? Who uses just one of them? Okay, a few of you. And the problem with using just one of them, and I'm going to assume that one is get, is that everyone expects you to have a uniform interface, which means you end up with situations like this, which I've actually stolen from a talk of Phil Sturgeon's, this screenshot, because it's probably one of the funniest things I've ever seen in a talk. Phil Sturgeon, my favorite WTF story is using a get verb to delete resources, which was interesting when Google crawled the API. Basically, Jamie here, his entire data source, thing was deleted because he made a mistake with HTTP verbs. Now, sure, he probably should have had authentication as well, but let's not go there. This is the problem, and this is why you should just not, why you should make sure you're using the right verbs. Google will not ever do a request to you with delete, because they know that's a bad idea. They expect that uniform interface. HTTP response codes. Who uses these response codes here? 200, everything's all right. 301, 302 redirects. 400, you made a mistake. 500 is I made the mistake. 401 or 403 is like, you can't access this. 404, I don't know where that is. 405, fix your HTTP verbs. This 405 one, if you're using Symfony and that kind of thing, it will probably do it automatically for you for routing. Who actually splits out 401 and 403? Who uses them the way that they're supposed to be used? Because they're actually completely different. These are a bunch of different HTTP codes that are also quite basic and apply to most people's situations, but they're probably less well used. 422 for validation errors. Who has validation in their APIs? Put your hand down if you use 422. Okay. So quite a few of you do, but there's still bandwidth there, and that's to say explicitly this is a validation error. A 400 doesn't tell me what I've done wrong. It might be authentication, it might be authorization, it might be that I had too many characters in my name field. But this helps people understand your APIs. Also, rate limiting. Who does rate limiting in their APIs? Okay, quite a few of you. When you hit a rate limit, don't just throw back don't throw back a 400. Say that you've hit a rate limit, because that allows people to build tooling around that. And then finally, 503. It's basically saying the API is unavailable, which might mean your database is down. Or you have some kind of service that means your API doesn't work. It doesn't mean that there was an actual error that was unknown. It just means that there was an error. So be specific. In Symfony, this is super simple. You can just do this in your controllers. What's wrong with this, though? There's something wrong with this. Yeah. So 422 is a magic number. It's just saying, hey, set this to this random response code. And the thing is that I don't know every single HTTP response code. I know a few of them. I know the ones on the 2 slides. But if you asked me what 517 was for, I would have absolutely no idea. So you can use constants. In Symfony has this, and as do a bunch of different HTTP response request libraries. Just say unprocessable entity. That suddenly makes sense to me. It's an unprocessable entity. It's a validation error. It didn't know how to process the object that has state that you were trying to give to me. And there are a whole load of these in Symfony. I hope you can't read this. I had to actually chop off a whole bunch when I was doing this slide, just to kind of try and fit them on. Errors. So errors in your APIs. Errors are really a bit of a pain, and a lot of the examples actually, particularly from here on in the talk, are from stuff that I actually did at my last company, Sam knows. And a lot of the stuff was actually built in a really nice way in order to make it really easy to build REST APIs. And a huge amount of that work was actually done by Stuart, who's actually in the audience. So I just kind of wanted to give everyone a wave. Yeah, that guy there is sitting on his phone. To be fair, he knows it. So I just kind of want to give a bit of credit there. So errors. A nice way to do this in Symfony is, so if say you have a validation error, you don't want to be putting that logic into every single one of your controllers. That's a huge amount of duplication, and it's quite a lot of code. It's maybe 15 lines of code in every single one of your controllers. And if you're trying to have 5-line methods, then that's not great. So a common way of dealing with this is doing an on-kernel exception event, which basically says if there's an exception, then run this code. And then it sets a response, and it builds a response with an error. But that's actually probably not the best way of doing this. It is a way of doing this in that you can always run code here and throw out a response when an exception happens. But if you're using Symfony specifically, then there's actually a way that you can just simply override the exception controller used by Symfony. Because Symfony will always handle your exceptions for a controller anyway. That's why you get the really nice, pretty page with the output if you're in development mode. So if you, and it can just look like this. So you'd have show action, you'd have your request, a flattened exception, and a debug logger interface. Logger is just your standard logger, and you've got your request there, so you can see exactly what was coming in. And the exception is just like a friendly exception to use instead of the actual original exception. And building this is really simple. So you want to say, get the status code for that particular exception, which theoretically should be one of your HTTP ones, hopefully. I've then got this get error method, which I'll talk about in a moment. Generate a JSON response, set some of our headers, because remember, we need our meme types in order for it to be RESTful. Return that response. Looks a lot cleaner. Then on the next level down, we actually need to be able to handle what that actual body of that message should look like. In this case, what we're doing is we're having a look at an error map, which you can see really small defined in the corner. It's got just a couple of things on there, because you don't want to have a big if statement of if it's a validation exception, then do this. If it's a 403, then do this. If it's 404, then do this. In this instance, there's actually some nice stuff here to sort of say if it's in debug mode, then give some extra output. But essentially what we're doing here is we're just grabbing the code, we're grabbing a message, and then if it's a validation exception, adding any of that. It's really nice, it's really simple to read, and you can just follow it line by line. It makes your code a lot cleaner than having to do this in every single one of your controllers and handle all of your cases there. Because the other thing to bear in mind is earlier when we were talking about uniform interface and meme types, if you're requesting JSON, you should get JSON back. The worst thing to have in an API is that you do a call, and then suddenly you get back a 403, but it's not in JSON, and it's in HTML or something. You can't be expected to parse that. I don't want to be writing an API client and then suddenly have to learn to handle HTML for your errors. Next thing I want to talk about is DTOs. Does anyone know what a DTO is? Okay, good. About 3/4 of you. So DTOs are data transfer objects. Every single object in PHP is designed to have two things. It's made up of methods and properties. Properties are how it stores its state, and methods are how you modify its state. Methods are doing things. Properties are if you look at all the properties, it will describe what that object currently looks like. The thing is that in PHP, we also have a tendency, instead of to use objects, but to just use arrays for things. So we might have an array of all the different pieces of request data. And we would pass that around maybe as a series of options. Or if we decode some JSON from a request, what we might do is we might put that into just an array of, okay, well, the name is this, and their address is this. But you've got no typing on that. One of the things that we now have in PHP is we have this ability to move the complexity in our applications using types. So we can actually get PHP itself to make sure that we're enforcing those types for us. And DTOs allow us to do that. We can pass around this object that we can then type in against. We can say, I'm expecting a user creation DTO. I'm expecting a DTO that describes what my filters should look like, or my sorts. And this allows us to basically never have to deal with these arrays with these miscellaneous fields. And how many people have made a typo with like name or something like that when they're passing arrays around and then they're trying to hydrate stuff and they have 20 lines and it's like $data name equals like controller data name or whatever, and they make a typo. So this can help reduce bugs as well, because everything will hopefully autocomplete with your IDE. In Symfony, you can use the param converter to basically hydrate your DTOs for you. So if you use the param converter and you combine it with DTOs, you can make your controllers look like this. So what we've got is we've got a post address action. So we're creating an address because it's the post verb. We're just type hinting an address create DTO, and we've got that as an argument passed in there. We're expecting a response. And I'm actually just calling this one method which says map and persist this DTO into an address. But what's creating this address create DTO? Why can I make my controller look like this? The answer is, and this is one of the things Stuart built, data transfer object converter. So you can essentially extend the param converter, which normally gives you things like request, and it also allows you to sort of inject things into your controllers as arguments. You can actually say, okay, well, if I'm type hinting a DTO, how should I translate my request body into hydrate that object? So what we're doing here is we're grabbing the content of our response. We're saying, what's our response look like? We're then getting the class. We're denormalizing it using the serializer. So we're taking field for field and mapping it. Populating our object, and then basically just setting that on the controller as our actual object that we've just essentially built. Because this DTO here would be a copy of that object. So just in this line of code, and what we've got here, we're now taking whatever our responses look like, we're defining them as objects, and we're hydrating those objects, and then we're just passing it off to this entity persister, which says map and persist address create DTO to address, and this would then return to me an address entity that has been persisted to the database. I've made my controller so much simpler just by having to add a few lines of logic. And this works my entire application. I don't have to write this for every single DTO. I'd obviously have to actually write my DTO with the fields. But we've just simplified so much logic out of our API. It makes life so much easier. Validation. How do we handle validation? The simple answer to this is exceptions. The idea of an exception is that it should be an exceptional case. But the thing is that that assumes that you're building towards the success case, and that anything that doesn't match the success case is an exception. That's not really true, because when you're building your applications, you should be expecting edge cases and exceptional cases and failure cases. The wonderful things about exceptions, you can throw them anywhere, and they just get bubbled up. If my controller is looking like this, what you don't see here is that this is doing validation on two different objects, actually. It will be validating on my address entity, and it will also be doing validation on my DTO when it creates my DTO. But you don't have to see that every single time. You don't see the fact that it's running that check. You also don't see the fact that it's handling what that response should look like, because when we were looking at our handling of exceptions earlier, that's all handled in one place, which is nowhere near your business logic for each individual entity that you have. Remove control from your controllers. The don't do is valid in your controller. Is valid in your controller is really deep in terms of what it's actually expecting you to understand. It does like is valid. You're running an individual check on that DTO. You have to then suddenly introduce logic. All you want to do is you want to be like persist this, and then if it doesn't, you want to have the exceptions coming back up. In this case, what we're actually doing is we're trying to persist it, and if we're not, we're then throwing a brand new kind of exception. We see a validation exception, we handle that, and we then throw an error response. Because you might want to actually use that validation exception somewhere else. And then finally, we're just returning a created item. This is sort of standard Symfony function, but with a helper on top. So this would automatically make sure that we're throwing a 201 and adding that root in there. So this is the entire controller for creating an address. It's really simple, right? Makes life a lot easier. It looks really clean. We know exactly what it's doing. And we've abstracted our logic, our business logic, basically into a DTO. So we've talked a lot about input. Let's talk a little bit about output. The Symfony serializer component, it allows you to essentially put your, it can also do hydration of objects. One of the other things it can do is it can manage your exporting into a certain format. So say that you want to be able to support XML and JSON. Again, you shouldn't really be having to care about this on a day-to-day fashion. You shouldn't be having to do JSON encode this array of data and then just spit out some string. You should be able to say, hey, I want a JSON response or I want an XML response. And the Symfony serializer can do that for you. And the next kind of step of this is, okay, well, I still need to know what those various different fields look like. And that's where transformers come in. Transformers essentially migrate, they take the data that's inside your entity. So if I'm doing a get on an address, it has a series of different fields. And each of those individual fields, I might want to rename in my response. If we go back to our principles that we mentioned earlier, you shouldn't have to care about what's in your data storage or what's in your database. You should only be caring about resources for the user, which might not even correspond to your entities. So build transformers, which essentially allow you to define what your responses should look like when someone requests an individual resource, and they're responsible for building all of the content for that. So you would have a transformer for your user, you'd have a transformer for your address, and you also have the option for includes and stuff like that. So we'll have a look at what that looks like. I've used a library called Fractal quite a lot by the PHP League. It's a really nice quality library. It's well maintained. It follows good standards. I'd really highly recommend it. But I'm sure there are probably some others for transformers if you have a look that do similar things. So this is what it looks like. Following on from our address, we're saying we've got this big transform method. We pass in our address, so that would be our entity, which we've fetched. And I'm now defining the individual fields that I want. So I'm saying, okay, the ID, address line, county, city, postcode, country, created at. And you can see I'm doing a little bit of logic here as well. I'm saying I want to get the timestamp. If it doesn't exist, then just return null, so that I'm not sort of doing a get updated at and potentially receiving an object back or some ugliness there on the get time, not running the get timestamp method, sorry, on the on a potentially null object. The other advantage of this is that there might be stuff in your database that you don't want to be exposing to users. And sure, even if you're like, okay, I've created this address object, everything in this entity I want my users to see. What you don't want a situation for is for a junior developer to come in 6 months later and be like, hey, I want to add a new thing to this address entity. I want to say whether or not it's archived or not, because I'm implementing soft delete. So they add an extra field, which is designed very much for the database. And if they don't have this here, then they don't ever have to consciously think about the fact that, oh, that's suddenly going to appear in responses and actually change our API output, because it will just automatically appear. If you've got transformers like this, then it means that it won't ever appear in the response until you're explicitly telling your application, I want it to appear in my response. You've also got stuff like the available includes. So the idea of that is that you would then have extra methods for each include. To say, hey, I've also got an address object that I care about, and I want to include that in the body of this for side loading, essentially. It's great for relationships. In order to use it, these are just examples that are straight off the Fractal website. It's really simple. In order to be able to get the response for that, if you're looking at an individual one or if you're looking at a collection, just book or books, and it will automatically do a series of formatting on that. So if you want that in XML or if you want it in YAML, then essentially you're just saying create the data and put it to JSON or put it to an array or put it into something else. You could then use a Symfony serializer in order to do that. The other thing that it will give you is that these create data methods, you can tap into these and you can say, hey, I also want you to do hey OAS for me, or I want you to do pagination. This collection object, what this will do here is this will automatically do pagination if you're passing it the right arguments of which page you want, etc. So I'm just saying I want books, but books is a pagination object. Pagination. Who likes pagination? Great. Nobody likes pagination. No, you put your hand up too late, so it's fine. Nobody likes pagination. It'd be really awkward if people had actually everyone put their hand up. The thing about pagination is that it's a bit of a pain in the ass, right? If you're ingesting it from the client side, then it's a case of, I've got to now write logic in order to be able to work out what the next page is, and then keep iterating through these pages, and great, I can no longer write my applications in Bash. Yeah, it's because you shouldn't be writing applications in Bash. You should be writing it in PHP, right? Yeah? Okay. But also from the server side, it means that you've got to add a whole load of extra logic. You've got to handle limits. You've got to handle passing that through your application from the controllers. And you've got to do this on any time when you're getting a collection. So, how do we do pagination? Let's have a look at to-do list. One, you've got to do it. You can't just rely on the fact that any client consuming whatever you're sending will just be able to take a huge stream of data. You've got, particularly if you start to scale up, that can become a problem for people. What your defaults are is obviously up to you. Having a way to disable pagination can be useful, but again, if you're looking at like 15,000 different items in a collection, that's a huge amount of data. You probably don't want anyone just like hitting one URL and grabbing all of that. If you've got rate limiting in place, then that's another thing to bear in mind when you're doing pagination. Going back to our principles and uniform interface again, and hate OAS, link to the next and previous pages. HTTP has you can use hypermedia in it. You can do links, so do them. It just makes life easier instead of having to code logic to be like, okay, well this is the number that I need and this is the URL and I've got to build these and then I've got to create that request. Just have it so that it can just follow. It can basically click through because clients can do that. Say the current page number you're on. It's useful for debugging more than anything. And detail the total number of pages. I say this with a caveat. Detailing total number of pages assumes that you've actually done a count on the entire data set, and therefore you know how many rows there are. But actually, disabling a total can make things so much quicker. When we were at Sam Knows, we spent a huge amount of time on this, in that basically all of these endpoints were really, 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 really slow, and we couldn't work out why. We're like, it's only returning 10 results, right? It's doing a limit 10, it's doing an offset. Why is it taking 30 seconds to return 5 results when we're just grabbing a random 5? And the answer is that particularly if you're using projects like Doctrine's Paginator, sometimes they're automatically doing a whole load of counting for you. Sometimes it's like select all and then running a count on that result. So that's why it was taking 30 seconds. It's because we were actually doing a select every single row and then doing a count on that. So if you find a way, if you can disable your totals, then it can be a really convenient way to speed up your application. Maybe offer that as like a client-side option. There are a couple of libraries to do this for you. I would not recommend doing your own pagination. There's Doctrine Paginator and there's Pagefanta. They're both quite reasonable, but bear in mind you may have to do some customization and some tweaking, particularly for performance. As I mentioned, like sometimes with totals it can just go a bit wild. And the advantage of both of those is they both have fractal integration. So as I was saying earlier, you can just do on a repository, you can do find all, and then you can just return a success and just pass in your paginator, and then later on you're passing that you're passing that straight into Fractal, and it's returning your response. We want to have really simple controllers. Creating new resources and adding them to be able to create them and list them and get them should be really, really, really simple. What we're looking at here, though, is you'll notice I've added an extra parameter onto my controllers called grant filters, because ultimately I need a way to get it to my repository. I need to be able to, I've got my different page numbers, I've got, I know that I'm starting on page, I'm on page 5 and that I want 20 per page. And I need to get that down to my repository so that it can handle that in terms of limits and offsets. How can we do that? We can do that through this user filters object. How are we creating that user filters object? Similar stuff with the param converter. It's also doing a lot more. So, leads me very nicely into sorts and filters. Who has implemented their own way of doing sorts and filters in an API? Almost everyone. That's because a really nice solution for this doesn't exist, generally speaking. It's actually really simple to do, though, because there's an object for that. If you're looking at your request body, here we've got page 1, we've got per page 20, so we've got our pagination arguments, we've got sorts. I'm sorting reverse by ID here. I'm including groups and addresses. That links back to the transformers I was saying earlier and side-loading other objects. And then finally, I've got this filter. I'm looking for the name Michael on my user's endpoint. And my controller just looks like this. I've got address filters. I'm getting my address. Very simple. What does that filter object actually look like? It looks like this. Get user, set user. That's super simple, right? That's all I needed to do in order to build some filters for this one endpoint from a controller point of view. I'm using a couple of traits, pagination and sorting. Sorting is basically, it just builds an array. And pagination, again, it just builds the page and per page number. I can populate them from fields using the param converter in the way we saw earlier. In the repository, we have to do a little bit more logic. So we've got this into the repository now. We've got our filters, we've got our sorts, we've got our pagination. We're creating a query builder. And then we've just implemented a couple of helper methods here. So we've got add filter and we've got add sorts. And because we're passing in our address filters DTO, we just call get sorts and get our user on our filters. We then implement those two methods. So add sorts, this is generic. This works for your entire application. So this is one base repository that you might extend or a trait that you might use throughout all of your repositories. So you simply look at the sorts. You do, if there are more than one sorts, then you add order bys. Very simple. If there are filters, then you will need to do some funkiness with grabbing the name and the value. There's a map of names of the filters to what they would correspond to. It's useful for joins. And then you just add wheres and set parameters. Again, we're just making this really simple in order to try and make sure that we're not having to do all of this logic in every single one of our repositories. This repository is simple. It's easy to read. I can see the business logic that's going on here. I can see I'm creating a query builder. I can see I'm adding a user filter, and I can see I'm adding the sorts that I have been passed. And then I just create my pagination object. And I, again, have my per page and my page there. I don't want to be having to deal with all that logic. And this is just a really simple way to abstract it away. So tools to do this. Some of this stuff, sure, you'd have to build yourself in terms of I mean, it's 10 lines of code for some of these things, snippets. My slides will be available afterwards. But there are some nice tools that can kind of give you a shortcut into building a lot of this stuff. The first one is API Platform that I'm going to talk about very briefly. API Platform is great. It allows you to really, really quickly build APIs. If you have a Symfony application, then using it is as simple as typing composer require API, and it's kind of there for you. And in order to kind of, I'm just going to do basically a quick demo in order to kind of show you the different kind of functionality that's there. So if we have a look at that. So this is, So this is an example of the UI that API Platform already spits out. So we can see a whole load of endpoints for this books object. We can see it's correctly using verbs in terms of it's got a get, we've got a post, we've got deletes, we've got puts. I can have a look at one of these. It shows me sort of an example of values. It lets me change a different format here, so I can have a look at XML, I can have a look at JSON. So it automatically builds all of these different formats into your REST API for you. You don't want to have to manually sort of write all the logic for, okay, I want to support all of these different formats, because let's be honest, you'll probably just end up writing something for JSON. Not everyone wants to read and write from JSON. It's quite simple to add others. You've got your different fields here, and as you'd expect, again, it does all of your response codes for you. So we're looking at 404s. Can't find the resource, can't find the book you're looking for. 400, you made some mistakes with your input. 200, etc. And what this is all actually built from is essentially objects that look like this. So I've got my this is actually the same code that was powering what you were just looking at, by the way. So here I've just got an entity called book. I'm doing a little bit of jazz here in terms of I'm saying the schema. Don't worry too much about that. I'm adding my ID, and I'm just basically defining my fields. I'm saying, okay, this is an ISBN. I'm saying that this is a book. It's only a read-only field. I don't want to be able to let people modify it, and so on and so forth. It's really simple. This is basically the only thing that powers the API. And the thing I really want to draw attention to, which actually you can't really see at the back, there are no controllers. There are no DTOs here. There's no repositories, there's literally just entities. And everything was just generated for me. It's the easiest possible way to build a CRUD API where you just want to do updates, reads, writes. And then sort of going on, the other really nice way, if you want to have a bit more control, you don't want to sort of give everything over to API Platform where you're just building entities and it's doing everything for you. Earlier when we were talking about exceptions, the one problem with that is that we had this map, which was in PHP, and we had to do a bit of the implementation ourselves. With FOSS REST bundle, you're just configuring that in YAML or JSON, and you can just say, okay, well, if you see this particular exception class, it should be this code. It should be, and you can use your constants there as well. And you can also specify specific messages as well. In order to handle things like the handling response format, so YAML, or is it JSON? Is it maybe it's an HTML response? I don't know. And also being able to handle transformations. They have really simple helper methods for that. So set template variables, etc. It can also automatically build all of your routes for you. So if you just say, hey, I want to have users controller essentially as a source of routes, it will, and you have get users action, post users action, these methods exist, it will then automatically just create those routes for you using the correct HTTP verbs and directing them in the right way with slugs, etc. when necessary. So just to kind of recap and just as to what we've talked about. First of all, we talked about the principles of REST. We talked about making sure that we're using HTTP well, making sure that we're using our HTTP verbs, making sure that we're using our HTTP response codes. We talked about error handling and how to make sure that we're not handling things like validation exceptions inside of our controllers, but just abstracting that away, making sure that our errors are using exceptions, and then that we're handling any kind of exception to make sure it's in the right kind of response format. We talked about DTOs and the param converter in order to be able to basically abstract that logic and sort of have these weird maps of this string is this string, or trying to have mistakes in our arrays. We can do that with DTOs and param converters where it all gets done before it even hits the controller. We talked about validation and how we can make that really simple and abstract that away, making sure we're bubbling up those exceptions, which we can then just catch and rethrow. We talked about formatting output using Fractal and looking at transformers. We talked about, there's two at once, that's exciting. We talked about pagination and how, one, unfortunately, we kind of have to do it. But secondly, it can actually be quite easy to do and to pass that all the way down into our repositories. In the same way that we pass our sorts and filters straight down into our repositories. And we make our repositories look nice, we make our controllers look nice, and everything just kind of works, right? That's the idea. And then finally, we just had a look at a couple of tools that can kind of help us along the way. Thank you very much. We've got a couple of mics for questions. I'm also quite happy to take questions on anything else relating to APIs. I don't know, maybe you want to ask questions about versioning or whatever. Floor is open. Let's have a chat about APIs. Yeah.
Maybe.
Yeah.
Just a quick one, because you mentioned about the HTTP codes that you are using for the response codes, and you mentioned 301 and 302. And as far as I know, they have been superseded by 307 and 308. But obviously, what's your opinion? As in, should we really use 307 and 308?
I'm still using 301 and 302. I haven't looked into 307, 308 that much, if I'm honest. Maybe I should. I will have a look after this talk, and I will get back to you. If you drop me a tweet, then yeah, we can have a conversation about that after.
Have fun.
Yeah, regarding this API, right? Whenever we are like fetching the huge data, right? Let's say huge data, you are always trying to hydrate the things and then process the thing. Can't we use the raw kind of things, raw SQL provided by the doctrine, right? And process the thing and just bypassing the thing. Because normally, like when you got like huge table, like if you need to export it on any format, doctrine just preload it in its memory and try to hydrate it and then export it, right? Which is virtually impossible, right, to export the data in any form. Can't we do that way in order to increase the performance of our application?
Yeah, so when it comes to performance and doctrine, it can get a bit complicated, and sometimes yes, you get to a point where you're basically writing the queries instead of using stuff that the ORM might do for you. Using the ORM is a really nice, simple way of managing stuff. Doctrine allows you to do a lot with it, though, in order to fine-tune performance. So say that you have in your transformer, and you know full well that you're going to be including, if you're looking at a user, and you're going to be including an address and maybe like their comments on a blog or something, then you can automatically preload them, but you can also say that actually you don't want those to be selected by default. You want them to only be loaded when it's actually requesting them. So there's a lot of stuff that you can do there. As I mentioned, the doctrine paginator, there's a whole load of stuff in terms of the queries it will run, where it might do a whole load of joins, and then it's doing a select, and it's essentially doing a select, like a select star on one table, which is joined to like every other possible table it could be joined to, which is sometimes really, really unhelpful, particularly if you know it's a one-to-one, because it's just selecting data for no reason. So yeah, there's a lot of stuff you can do with doctrine optimizations. You could spend months on it. I know that people do spend months on it. We at Samno spent a huge amount of time trying to optimize all kinds of different endpoints of doctrine. So yeah, there's a lot of stuff there. Yeah, there's one there. How to get there.
Hey, great talk. Just wondering, how would you differentiate between a 404 because the root doesn't exist, or a 404 because the object the person's trying to get doesn't exist? How would you recommend handling those sort of differences? Or say, maybe the user doesn't have permission to hit that root, or they don't have permission to get that object, like a 404 401 or 403, whatever the correct one is.
Yeah, so I mean, you've already answered half of your own question. In that, if they don't have access to that, you should be returning 401 or 403, depending on if they're logged in, or if they're logged in but don't have access or not logged in. The other side of that is that if the URL that you're requesting, if the resource you're requesting is user number 32, that user doesn't exist, which means that root doesn't exist either. It's the same thing, because the user ID is part of the resource that you're requesting. It's part of the URL. It's part of the URI. So you're requesting /user/1. That user doesn't exist, which means that root doesn't exist. The root exists when the resource does. So it's a bit of a mindset thing, I guess, in that like whether or not I guess the question you're really asking is perhaps. Are you saying about maybe /users doesn't exist, or is that the?
Yeah, I guess so. Yeah.
I guess that's a problem we haven't solved with HTTP yet. In that we just say that whatever you're trying to request, the resource that you're requesting doesn't exist. We don't say at what level that doesn't exist. We don't say that the 3 folders that are higher than it, the 3 parts in the path that are higher than that in the hierarchy don't exist either. Yeah, I think that's an HTTP problem that we haven't yet solved. But for now, we could just like delete the characters at the end of the URL and see when it starts to work. Sorry.
Hello.
Oh, hi, that was loud.
I'll hold it a bit further away then. I've not actually used Symfony myself, so I was just wondering what the decision behind using Symfony for REST API, building your REST API was, and whether it has anything specific for building REST APIs that something else doesn't.
Sure. So so Symfony, PHP is a great language for web stuff, right? And a subset of that is APIs. So therefore, in my opinion, PHP is also quite good at generally producing APIs. You then have a series of different frameworks in the PHP community. You've got Laravel, you've got Symfony, Cake, CodeIgniter. The thing about them is, and a lot of framework choices end up coming down to some of it comes down to like what experience you have in a team. Some of it comes down to sort of how well maintained it is. Obviously, there are frameworks out there that haven't really been maintained in a long time. In terms of Symfony and what it has specifically, I would say things like the param converter, but like can really, as I was sort of showing earlier, where you're basically building those objects and it's doing it all for you. But that said, Symfony is just a set of components. It's just a set of libraries. There's no reason that when you're building a Laravel application, you couldn't use those components. But in the same way, when you're building a Symfony application, if there's a really nice Zen framework component, then you could go and use that. So I kind of, you don't have to build it on Symfony in order to use Symfony components. So the answer is kind of no. In terms of APIs very specifically, there isn't a reason why you should 100% use Symfony over Laravel for APIs. The reasons that I would suggest you use Symfony would probably be different than that, and that's a very different conversation. But yeah, does that kind of answer your question? Sorry, it's a bit of a non-answer, but what was that? Sorry. So you're saying about the microkernel in the FOSS REST bundle. I'll save you running, sorry. So yeah, so there is stuff in Symfony that basically allows you to build. So with Symfony Flex, you basically only grab in the components that you need. You don't have to pull in the entire framework. The full stack framework for Symfony doesn't exist anymore. You just request the components that you need, so you can have something that only has the components you need for the API. If you use Laravel, you have to pull in basically all of Laravel at the same time. So yeah, it's a good shout. It's a good shout.
Yeah. In terms of the authorization and authentication, right, response code, do you recommend to send the right response code or 400 will be fine?
Send the correct response code in which case, sorry?
I mean, authorization and authentication response code, right?
Yeah.
Do you recommend to send the right response code or 400 will be fine?
Yeah, always send the right response code.
Or,
401, 403, yeah.
because don't you think it will be the security risk if you send it right error code for the hacker?
I mean, if your security is based on the fact that someone can't guess auto-incrementing IDs or UUIDs, then that shouldn't be where your security is. It shouldn't ever be insecure to say, well, to be fair, you shouldn't use auto-incrementing IDs, just generally speaking. Otherwise, someone can go, hey, I want to go to user ID /5001 and see if that exists. If any of you ever submit CFPs or using OpenCFP, you can always see how many talks have been submitted to a conference by basically submitting a talk and seeing what your talk ID is. OpenCFP. I love OpenCFP, to clarify. It's just like a little tip there. But yeah, so UUIDs are basically you're just guessing random IDs. If you happen to find one and it says it exists, like if that's your security vector, the fact that you can find out that something exists but you don't have access to it, that's security through obscurity. Your security should be the actual authentication itself. And just don't use auto-incrementing IDs. Then you're not giving anything away.